I'm very happy to be here this afternoon talking to you guys about STEM education in a classroom, also discussing the amazing resources developed by Cambridge University Press in this partnership that started roughly 18 months ago. I believe Paulo already made an introduction. I live locally. I started my secondary education teaching career here in the West, in Werribee, Wyndham Central College, and I'm really excited to be talking about this new project here in the West. And I worked closely with some of them, with these students in a very disadvantaged situation and background. And it turned out that STEM education was something that made education meaningful to them and gave them an opportunity to move ahead. And I'm happy to be discussing this with you here today. This is what we're doing. We're defining STEM today. We also will attempt to develop an appreciation for the importance of STEM, gain a better insight into STEM education, see some examples, and discuss the challenges in schools. Any of the teachers present have any experience with STEM education, developing curriculum? There you go, 1, 2, beautiful. 3, 2.5, yeah, beautiful, yeah, good. So forgive me for what I bring here is already known to you. This is developed for a wider audience, and I'm really happy to have your contribution as well. So STEM 101, knowing that you are familiar with STEM, I would like to give you some paper and get you to populate the paper. I'll give you like 2 minutes with some ideas, words, sketches, sentences. You can draw ideas that connect you with the concept of STEM education. So for 2 minutes, and we can have conversations about that. So for 2 minutes, I'll give you an opportunity to populate the paper. If you go and check the research, they will be telling you that the STEM education is everything that is in the definition there. The word that I think should be highlighted there is interdisciplinary, which is integrated approach, and that's something that was listed in your activity paper. I'll give you an example of what a STEM project could be. We run this STEM project with a number of students here in the West, and the idea was to build a raised garden bed. So we started with this holistic approach, and we talked science. So in science, we talked about sustainability. In technology, we used 3D modeling software to build that garden bed. In engineering, we went down the engineering design process that you mentioned, which is extremely important. And then the mathematics, some budgeting, how much sand do I need, how much soil do I need. And this is the ideal, the holy grail of STEM education, as we see. But we have a number of challenges out there that we'll discuss later on that sometimes prevent us to get into that goal. So for the importance of STEM, I remember when I started researching STEM education, that process, it started when I realized that STEM is all around us, all around us. If you have a look at that image, the lady has a mobile device, has a laptop, has that little device at the top that's sitting on a laptop that generates a key, a password every 30 minutes. I used to use those when I was working in industry, and it was cool, but people don't use those technologies anymore. And we call that technology, I call that, for example, the mobile phone, I call that consumer technology, because it's a collection of technologies. A camera is a technology, and the science for the camera, for example, you have to understand how light works, optics. And for the touch screen, you have to understand a little bit of material science, how the glass works. And it's very easy to start using the mobile devices and forget that we're talking about a collection of technologies, a collection of inventions working together. I remember when I used one of those, long time ago. It was boring to use, it was heavy, the battery wouldn't last very much. Texting, it wasn't comfortable, it wasn't. You make a mistake, you gotta go back. And that idea of a mobile device, at the time it was cool, walking around with a mobile phone on your hands. And today we have the innovation coming in, I know that was a flop. It didn't work really well, but we now have foldable devices coming. I remember when I used my first touchscreen device was a Nokia phone using old Symbian system. It was okay. It was really okay, but when the Samsung came, when the Apple came, you can see these innovation leaps coming. And it's all to do with innovation, or those new methods and ideas and products. And in my personal opinion, we forgot to talk about innovation with our students sometimes in a classroom. So for example, if we go back in time, let's go back in time 3,000 years ago. 3,000 years ago, we go back in time, and there's a time machine, you get inside the time machine, and there's this cave people there. And they are about doing their business and doing things, and you come up with something like this. Say, have a look. Have a look what I can do with this. They will think you're God. So, oh my goodness, how is that possible? So we were writing tablets before, the Babylonians in tablets, and we evolved. Sometimes we don't think about that innovation very much. So I want you to think about some innovation now. So I'll give you a scenario, and you will have to write a little bit. So there is this small town in Equatorial Africa. That's a scenario there. And they experience a lot of grief from time to time with flooding, okay? The flooding makes their life impossible and makes really, really hard for kids to go to school. So thinking about a simple solution, it could be a product, it could be a service. What could you do to enable students going to school during the flood period? So I'll give you a minute. That's the reality of this, where these people live. That's their reality. So a German charity helped them build a floating school. So you went down the engineering design pattern and a little bit of design thinking and empathy, and we come up with something, they came up with something like this, which is remarkable. So it's flooding, yeah, it will float. And you can put the kid in a raft and off you go. In Nigeria, I'll give you another one. In Nigeria, housing, we talk about housing and affordability. Nigeria also suffers that issue, and houses are expensive, $45,000 to build one. So what could be a solution, a product or a service that we could be designing, creating for people in Nigeria to sort that issue? What could be one problem if you think about innovation? I love the direction you're going there, because you're basically telling me, correct me if I'm wrong there, what is waste for me could be resources for someone else. Yeah, that's what they've been doing there, building houses with old bottles, the plastic bottles. So they have an issue there right now where they cannot find rubbish on the streets. It's a big issue. Big issue in Nigeria. Yeah, so they don't, yeah, I was reading. So we're struggling, we need bottles. Yeah, so they put sand inside and mud around it, and I'd like to highlight that it's bulletproof. So for that reality, exactly. Yeah, so for us, exactly. So for us, that wouldn't be a consideration, but for them, yes, it is. Yeah. We have a number of challenges for STEM education in Australia, and some of those challenges mostly come from the fact that we have some confusion in the education system, in the industry, and policymakers. So in some areas we have some inertia, and we have lots of actions in other areas. So if you following the news, we have an issue right now that we are not getting graduates in STEM as we were 10 years ago. So the numbers are going down. And one of the most complex issues that we have is that women are only 16% of Australia's STEM workforce at the moment, which is not desirable, not good. If you have a job in STEM, you will not have an issue to find a job. What we have today is the aging workforce. And if you have a look, astronomers, chemical scientists, earth scientists. They are old and they are about to retire. And the younger generation, they are going to computer science, and we don't have a replacement for those skills. So as soon as they leave, we'll have this gap. And that's something that we have to consider. We also are living the fourth industrial revolution, and this video here will show you what's happening in China right now. The Chinese are being extremely successful in developing some mind-blowing automation. This is a factory that belongs to Alibaba, one of the greatest, it's Amazon's main rival, and they have, I believe that in this factory, they have 60 of those robots, and they lift all the weight up to 500 kilogram shelves. They move the shelves around the warehouse, and because of that, 70% of workers could be replaced. So even in China, where the workforce is considered cheap, robots are automating everything. This is one warehouse with 60 of them. They have warehouses with 3,000 of them working 24/7, and they work in the dark because they don't need the lights. And that reality is making those types of skills more valuable today. And that's a report from the Foundation for Young Australians, the New Work Order. And it talks about the digital literacy, the critical thinking, and especially in the creativity, which at times with the curriculum that we have to present to our students, with the time that is given to us, sometimes we don't have the time to invest on those skills. The future, the new work order also has this infograph. This report is freely available at their website that shows the areas that we should be a little bit concerned. The one that concerns me most is the Indigenous Australians and kids from English as an additional language. They are finishing school and they are not proficient in maths. And there is this one at the very top corners, at the right corner. It talks about the digital literacy skills. So finishing at 12 without those digital literacy skills might also make our students suffer, because 70% of the jobs that they are getting right now, applying for right now, will probably be automated. So when I arrived in Australia 13 years ago, I worked as a dishwasher, washing dishes, not a dishwasher, washing dishes, kitchen hand, yeah. And I worked on weekends for Woolworths. So I remember that I had to type all the codes, blah, 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 blah. But today you just scan. And today I scan. I go there, boop, put in the bag. And I'm actually, yeah. So for kids living in school, those jobs are no longer there. McDonald's, I don't eat McDonald's, by the way, but if you go to McDonald's now, you can put your order via the system as well. Yeah, so we face a number of issues, and I'd like to commend you for being here today to listen about STEM education, because we as educators, we have an important role to get our peers involved in this major task that we have, that is to make STEM education more known out there in our schools. Okay, so STEM in action. I'll show you a couple of images of what STEM in action look in my classroom. We have students moving around. They own the table. They can borrow my laptop if they want to finish a task. They're on top of my laptop. They are writing. They are designing. They are designing on the board, on the whiteboard. They go to the whiteboard and they start designing. They start brainstorming, and we also give them an opportunity to start building some prototypes. So they come with idea, they use the engineering design process, and then they put some prototypes together. And towards the end of a project, we give them the opportunity to enhance the design, the digital technology skills by putting a video together, for example, showing how they progress through a task. So my students created this video to show how they tackled a 3D puzzle challenge that we made with them. So they went through the design process. We gave them a set of requirements, and they designed this puzzle that we would donate to people suffering Alzheimer's in the region so they can play with the puzzle and get their brains busy. We failed with that class because, yes, we failed. We failed with that class because they couldn't do the conversions from centimeters, millimeters properly. So when we 3D printed that, it was all wrong. But they learned. And then we ran another round and we finally had the product finalized. So it was important to them to fail and to realize where they failed and to improve. And they realized that the learning process is not a linear process. It doesn't go like this. It's messy. It's really, really messy. So the research phase, it's messy. And when they have the prototype, then there is some clarity and focus, and off they go. Now, for challenging schools, I would like you, if you want to, you can either voice, if you want to, or you can either populate the paper with the challenges. It's up to you. The challenges that you associate with STEM education in some schools. You don't have to voice it if you don't want to, but you can think about it for 30 seconds, and I'll give you a breakdown of what I've been hearing from teachers in Victoria. What teachers are telling is that schools sometimes will struggle to attract qualified STEM professionals keen to introduce integrated STEM education in the classroom. So this is what I'm also hearing from teachers, that they're siloing between faculties. So yeah, there are walls. Instead of collaboration, there is this walling, if this is a word, okay? And also you will have people saying, no, this is just another wave hitting the shore. I've seen this before. Now let's keep as it is. Early adopters like yourselves are keen, that's keen again, to try new ideas. However, sometimes it's difficult depending on the school priorities. Sometimes it's difficult, and you might even hear, we'll try that next year. We might try that in 2022. So you have this one, I believe you agree with me. So there's time constraints, sometimes lack of resources, yes. That one, would you agree with me? So there's a competition with VCE, and the one that you just mentioned, so there is this idea out there. It's like I'm a geologist, and there's this assumption that I love rocks. You know, but you love rocks. STEM educator, it must be coding. So there is this association, and it's starting to become like a stigma. It's starting to become like a stigma because I don't like robotics, so I don't want to hear about STEM. So the question is, if we have those difficulties there to talk about STEM, and you have some experience in having a network across Melbourne, which is great, how do we attract the bees? How do we attract the bees, your head of faculty, or the people that are not the early adopters like you are, people that are not as keen? It's education, and also this has worked for me. STEM activities will promote student engagement. And I've been running engagement surveys with my students over for 4 years now, and you have the non-STEM curriculum versus the STEM curriculum, or non-STEM classes versus the STEM classes, and the engagement is remarkably different. The average is 26% greater. Then you also have another keyword, which is another jargon there, which is your differentiation. Brings your differentiation to the table. In this case here, I think that's a video, you can see that we have a student mastering a topic, and that's balancing chemical equations, and we were doing that we were doing some soil sampling, so this was part of the journey. And there she is explaining to another student how to do it. This is a topic that we teach at year 10, those are year 8 students. Those are year 8. That other student in the corner there is observing. I'm not sure if I should approach, I'm not sure if I should participate. But later on, after realizing that the first 2 students managed to get everything right, then she approached and said, can you please tell me how I do this? So that's a little bit of your differentiation there. Activities will also encourage students to gain those 21st century skills, which are part of the digital technology curriculum. And for this textbook that was developed, I suggested this activity, it was accepted, I'm glad with that, this activity for the year, I believe it's year 7 curriculum. When we talk about seasons, when we talk about the solar system, so the idea is that we create the solar system using Microsoft Excel, and we get it to spin at the planets to actually orbit the sun at their actual rate. So Mercury, the fastest one, that 1 second is equals to 88 seconds. Venus, the second one, that I believe it's 2 seconds will be equals to 100 days, and Earth is roughly 3 seconds. So students, if they follow the instructions, they will be able to do that. STEM activities will also link to your empathy and real life scenarios. We also developed an activity where we talk about the effects of the earthquake in Nepal. And you can see the rubble at the back and the kid drinking that water. And we discuss, is that water, is that clean water? Is clean water our human right? What are the adverse consequences of not drinking clean water? And so forth. And when you build the empathy, when you have that intrinsic motivation, then you can actually design something that makes sense. It's about developing that intrinsic motivation. And some of those activities will also deal with complex issues. Another activity that I suggested to Naomi, which sits over there, and it took me a while to explain what the activity was about, but I'm happy. Yeah, I'm happy we understood the goal of the activity, and this activity discusses the challenges presented by landscape modification. So if you have a look there, that's our Werribee Hoppers Crossing area there, and we use satellite imagery to create a time lapse that tells a story of what has been happening over the past 25 years in our region. And the end of the activity is the end of activity is an application where the students will actually have to answer if it's safe to develop new buildings around the Werribee River. And finally, those activities will encourage the students to deal with failure, like mentioned before. I can see they were very enthusiastic about that. Yeah, dealing with the failure and discussing the process. And something that I've been witnessing today is that the students are asking for the answer. Just give me the answer. Okay, getting to the answer. We'll get there. We'll get to the answer. It's about the journey until you get to the answer. And yes, you will hit your face on the wall a couple of times until you get there. And I believe that the more we repeat that, the better we'll be. And to finalize this presentation, I'll just talk a little bit about this project. So I was approached by Naomi and Linda in late 2017, I believe, early 2018, with a couple of questions about how could we develop STEM resources that could be included in a textbook, and how could we do that? And after a number of conversations, this briefing was given to me. The activities have to be inspiring, and I agree with that. They have to be inspiring. They have to be relevant. We should, Naomi actually stressed with a lot of passion about the upcycling, the recycling. We should not use expensive materials. We discussed the challenges that would be involved with such activities because they could be no longer than 2 lessons. Of course, it has to be linked to the curriculum and replicable. For example, we developed this activity. It's an example here where we discussed the scale of the solar system. I believe this is for year 7. Yeah, we talk about the scale of the solar system. And the idea was that we take the students. So for this activity, we invited the students to have a look at how the solar system is represented by textbooks and by the internet. So we have the sun in there, and you have the planets equally spaced. Yeah, equally spaced, and probably the excuse is because we don't have enough paper to do this in a real size. They're equally spaced, and there's a lack of scale, I'm sorry. So there's no scale. And if you repeat this story to students at grade 6, grade 5, grade 6, year 7, 8, 9, and 10, you will believe this. You believe that this is actually true. And you put the asteroid belt between Mars and Jupiter, and they squeeze, and we don't think about those vast distances. So what I proposed as an activity was to present students with this table, and we get things to scale. So we say that the sun is at that wall over there, that's Paulo there, that's the sun, okay? And we have Earth 149 million kilometers away, but we scale this whole thing down to 1 meter. 1 meter. So if we have you as the sun, you are the sun. Yep. Of course. So if we go there, open, and get these as 1 meter, okay, that's where the Earth would be, in there. But then what we do is we invite the students to actually find a way. It could be an algorithm. We start having conversations about algorithms. Or it could be a mathematical way to get the scale right. And by doing a little bit of maths in science, which I do all the time, and they get surprised. Why are you doing maths in science? Well, it's the language of science, isn't it? It's a language that we use. We can create this conversion, and Mercury would be 40 centimeters, so it's really crowded. Mercury would be here. Mercury, please. There you go, 40 centimeters. Then Venus would be here, would be 72 centimeters. Thank you. And then you can really see that this scale, we cannot go to Uranus, or we cannot go to Neptune, because Neptune is 30 meters away. It's 30 meters away. So that just shows how the sun is really, it's really crowded there in the early solar system. And that's where the asteroid belt is here. Have a look. There's a lot of space for plenty of asteroids. So by doing this activity, we take the students outside the classroom, we go to the oval, we get them to, even if they can move around in orbiting the sun over there. And you can see that if Neptune is actually 30 meters away, we actually need 60 meters in length to be able to do an orbit. And you get them to think. I'd like to thank you for being planets, celestial bodies. Thank you. I'll collect this in a second. And there are many activities that we could be running in school, in association with the humanities faculty, maths faculty, all faculties, sports faculty. I'm trying to run a extemporary with the head of sports. He's keen to do it. We're going to put microbits on kids, little microbits on the kids' shoes, and see if they are accurate as speedometers. So we're trying to do that. So students will run 100 meters and see how many steps the microbit, which is a microcontroller that is roughly this size, like this size. It's smaller, but it will fit in students' shoes. It's roughly this size. If the technology can actually do the step count properly. I'm aiming for that by the end of the year. Hopefully it happens, but it's this starting those spot fires around your school with the head of with the science faculty, with the math faculty. You start those little spot fires, and when you realize you have this big fire happening and STEM happening in your school. And I finalize with this quote that says education is the key. That's actually, I believe, that the key for development of our global society. We are a global society now, and STEM education, it's not the solution for everything, but it's one of the many pieces of the puzzle. And today we discuss, those are the topics that we discussed, that we defined. We had a look at the role of STEM. We talk about challenges and opportunities. I believe there are much more opportunities than challenges out there. How do we attract the bees? And we can discuss that later on as well. How can we use some ideas to get people to actually listen and think about STEM education? And we discussed a little bit of the STEM resources. I believe that Paulo will discuss that at length with you. And there's some, I'd like to thank Naomi for her, and Linda for her patient work over this nearly 2-year period. And Boradeo for inviting me to present. Here's Sarah Dow. She works at Werribee Secondary College, and Liane Gagatsis, which was my former principal at Wyndham Central College. And I finish here, and we can have questions or we can have informal conversation if you want to.